Sri
Sir,
Balaji sir,
we are
if
live,
we
sir.
are
We are
live, can
live.
we
We are live.
start?
Please start. We are live.
Bhairavi Nayak, please start with the introduction now.
Yeah, ma'am, am I audible?
Yes, you are. Please proceed.
Okay. Good evening, everyone. Good evening, Chiranjiv sir, and thank you so much for joining us in. So, before we proceed, I'd like to just give a very small introduction that would describe how great and amazing sir is. So, Dr. Chiranjiv Roy, he is the VP and Head of Data Science and Applied AI Industry 5.0 at Course5 Intelligence. With 20 plus years in data science, with PhD in Applied Data Sciences, in incubating, leading and driving data analytics, engineering, science and AI product development across organizations such as Nissan Motors, Mercedes-Benz, Hewlett Packard, and HSBC Data Analytics. He has held multiple industrial track and workshop chair positions, is a member of the Analytics Society of India, and has been a key speaker in multiple national and international conferences, including Data Innovation Summit 2020, Cypher 2018, DataHacks 2017, and was one of the top 10 data scientists in 2018. He's an official member of Forbes Technology Council, International Group of Artificial Intelligence, and AI and Leadership Council. Thank you so much, sir. We are so very grateful to have you here. Now I would request you to start with your session today. Over to you, sir. Thank you so much.
Thank you, Bhairavi. First of all, to the entire management of IIT Madras, it's my honor to be on this platform and been talking to all of you. Everybody who is listening today, we will try to talk about something which a lot of people are today talking about, and there is an entire buzzword, right, around industrial and engineering, which is clubbed together from industry 4.0 to 5.0. Throughout my last 20 years, what I've learned, and of course, a lot of time being spent in major industrial firms, is something that I would like to share with you on my personal views, right, from the perspective. Let me go ahead and share my small presentation, and then we'll take it. Digital manufacturing is one of the most critical aspects which has been looked forward, and not just me, it's been talking about a lot of people, but this is my background. So since you're all from the master's and the bachelor's batch, right, primarily BSc to be precise, I've always been very included. My master's and bachelor's have been in statistics and then minors in physics, right. I do not belong to the engineering background, but I learned due to the course, right, during the course of the entire journey, right, in this perspective. I worked across Nissan Motors, Mercedes-Benz, Hewlett Packard. I'm a member of some of the councils and been very well contributing across the area, including a PhD in applications for data sciences in digital manufacturing and allied engineering. We all know him, Professor Andrew Ng, Google's brain, but he has founded an organization called Landing.ai. I'm sure a lot of people of you know him. He says that the manufacturing will touch every part of our society, which is the physical to the digital, right? And by bringing artificial intelligence to manufacturing, will deliver the actual digital transformation in a physical world. Please do understand, manufacturing, engineering, these are very crude subjects which primarily go into the major area of the work, right? Other than the finance part of the world, right? From the perspective, right? Why is he talking about this, right? Let's talk at where the world is talking about at this point, and primarily, let's say, Indian subcontinent, Indian market, right? The Indian analytics industry, to be precise, right? The industry 4.0 market is growing at a very, very rapid pace, and Asia will dominate a lot of work. Of course, there is a heavy lifting of the work which is happening in North America, manufacturing, energy, utilities, automotives, oil and gas company, aerospace. So from a needle to an Airbus, everything is getting produced. And manufacturing analytics, though had been done in picks and pockets, has not been there for a long, long time. And that's what the entire research academia, as well as the corporate, is actually getting into it. Of course, technology evolved over a period of time. Scalability was an issue. IoT first came into picture and started the digital automation where 3.0 to 4.0 happened, and that's what we are going to talk about. But the emerging fields, if you look at the left-hand side, right, from Analytics India magazine, manufacturing analytics is one of the core. How do we enter? But before entering, we need to, from a business perspective angle, because if you're not tied to the business part of the world, where is the growth, right? In Industry 4.0, how would we understand how to get about it, right? So the intelligence and the smartness needs to be come into picture. So it's a 11 plus trillion dollar market, from vehicles, from your cars to home to office to factory, retail, work sites, even the Fitbit or the smart watch that you're wearing. There is data. And to extract the data, you need smart intelligence coming into picture, right? You need to be real time, you need to be connected, and you need to be intelligent, right? From the perspective. We're all talking about sustainability, and that's one of the major core areas which will be coming into picture. But it's all about the data and the process. And then the entire allied services like artificial intelligence, 3D printing, video analytics, cybersecurity, robotics, human machine interfaces, smart devices, big data analytics, cloud, everything is the ensemble. This is what the business market is all about in Industry 4.0. So that means from India to the global community, everybody is talking about this. But are we ready? If you're ready, where do we stand? And if we have to get into this, how do we have to do it? Let's take an example where Industry 4.0 has lot penetrated, primarily automotive, because I come from an automotive world. It makes more sense for me to talk about automotive, right? If you look at this diagram, quite beautifully illustrated by right? Starting from designing of a car to end of digital manufacturing, right? From creating the door, putting all the spare parts together, putting and going into the service line, service implementation, power tooling, adaptive logistics, right? Aftermarkets. And then finally, when it goes to the road, you track the vehicle with connected. There is an entire landscape which is all with data. From design to running it on the road and then servicing that on the fly. So the entire product development life cycle, including the entire automotive landscape, automotives are at the highest of the maturity at this moment. Everybody is catching, but they started it much more faster, right? So they are catching up much more earlier, right? From this perspective. Now, we all understand digitalization, right? That has been very, very well connected. Industry 4.0 is all about connecting all the machines. You have to do customizations, and that's what Frost and Sullivan is also saying. Intelligent supply chains, smart products, manpower distance from factories. So there would be there are people sitting at home, and during the corona period, there is a huge amount of digitalization which has happened, right? Where people were not in the factory but able to work, and that will increase a lot more in Industry 5.0. So in 5.0, we're primarily talking about experience, not just a customer who is driving a vehicle or maybe who is experiencing a product, right? It is about even the service engineer who is actually trying to service your bike or your car. right? Or an engineer who is trying to rectify your ISP port on the road, right, would be getting an experience, right, through multiple ways, metaverse, Web 3.0, and of course, deep learning, machine learning, artificial intelligence. Customizations will be very hyper, right, scalable, globally accepted. Um, Supply chain would become much more distributed, responsive, and then primarily the experience of activated or interactive products would come into picture, right, from the perspective. But we are still a bit far from that, from the perspective. So this is the journey of Industry 4.0 to 5.0, which will be there. How many people or how many organizations are at 5.0? Very minuscule. But the world has already started, who have already consumed almost 60 to 70% in Industry 4.0, who are already data ready, who are scientifically ready. They've developed some experiments, already launched production level applications at different scale. Now, what are the key areas of work? And that I will come down to what we need to learn, all of us. The key areas of work that we see here is primarily digital transformation, right? It has to be very, very data-driven digital transformation. One of the bigger problems in the manufacturing industry is collecting data, because if you don't have good data, you will not be able to develop any kind of model on throughout. Most of the times, the data is not readily available. Even if it is available, it is not consumable, right, from the perspective. We'll talk about in one of the problems that we'll share today, right? You have to ensure business continuity. So you cannot create an AI system or a scientific system through which you will shut down a machine and then for a couple of hours, right, and you will develop something and implement and test and so on and so forth. So everything needs to be as real time as possible. You have to maintain the quality of the service. You need to be contractually flexible. Cost effectiveness is very important, and primarily the one that we are talking today primarily is about the scaling, right, in AI, ML, IoT, edge computing, and it's a mixture of multiple things. It is not about just knowing one of them. How do you know? So one, you have to come from a STEM background. A lot of you or all of you do come from a science background, though it is not that the people coming from the various other industries, for example, or subjects, let's say arts, commerce, right, would not be able to be benefited, but STEM as graduation streams, right, would be much more beneficial, right, from the perspective. It is not subjected to only engineering graduates. Let me be very open about it. It's all about your learning capacity. Yes, engineers who would have learned it over a course of 4 years, right, would have learned some programming languages, would have an edge over it, right, from the perspective. But it does not take you back, right? Of course, the effort needs to be put into picture. So what do we learn? So you need to know how to get data out. You need to learn data engineering. You need to learn some amount of full stack. So it needs to be productionalized, right, from the perspective. You need to learn the data analytics, right, which is inevitable, right? Python, Power BI, Tableau, so on and so forth. Then, since the scale of the data comparative is very high and productionalization is with amount of big data, right? It's a terabytes of data that gets generated from a machine, right? If you actually consider the log, and we'll discuss about it one, you're required to know the advanced analytics pieces, TensorFlow, Keras, Spark, PyTorch, and there are multiple ones which are coming in daily. So technology is changing every day, right? So you do not need to bother about that, but the fundamentals of the knowledge needs to be there. Finally, it's the core of the digital engineering and simulation, which is very important, right, in the engineering world. Again, it's a programming language based methodology. MATLAB, Gurobi, these are main, and Blender has come out very well in the augmented reality, right? There is a lot of metaverse based work, and even digital twins are developed through Blender, Python combination, and so on and so forth. Now it is the metaverse which is coming into picture, right, from the perspective. We use Gurobi to optimize things. There are works that I'm sure you would be doing, right, which goes into operational research, right, from the perspective. And we'll talk about it, maybe cost optimization, right? How much should I keep the price of a product in order to gain advantage over my competitor? That's one of the examples, right? Pricing optimization, right? How much manpower should I use if I have a fourth wave or fifth wave, something like that, right? If my factories go shut down, right, something happens, and I have to only have 25% of my factory workers coming into my factory, right? How can I use them optimally, right? So optimization, MATLAB, those are the key to the engineering world. This is the stack. You don't need to learn everything. You would have to gradually learn it when you go deeper into one by one. So in general managers, generally, right, in manufacturing, this is how we think, right? We have a business problem, right? There is a project management principle. We have to define a problem, right? Let's say there is a brand new design which is coming up. Let's say a battery. There is a new battery dissemination which is happening, or maybe a powertrain which is impacting, or it can be from an engineering field, right? From oil and gas, right? So we have to define a particular type of a problem. That's what a project manager does, or a general manager, or the DGM does, or an engineering manager does. When you get into picture, you need to apply your knowledge of, first, of your common sense, your consulting knowledge that you will learn, physics, mathematics, engineering, and technological know-how, to convert this definition into a discovery phase. How this problem needs to be attached. Please understand, never go ahead and apply models in the first place. Understand the problem first. If you don't understand the problem, you'll never be able to solutionize, right? Then it is expected, of course, you need to take out data. You need to know how to take out a data from a windmill to a car to a factory, bus, and so on and so forth. You need to know the nuances. There are different nuances which are already available, right? Analyze the data. Exploratory data analysis is very, very important in this field, right? Along with your knowledge that you bring into the picture from your erstwhile physics books, right? In some of the problems we have been actually going into books of Professor H.K. Verma in physics. That's the level that we have gone into, right, to learn, right, from the perspective, and that solves the problem. Then once you have a data science solution attached to it, and you have a buy-in from the project manager or the problem solutioning client, right? You develop you develop a plan to get into a product development team. There is a software development team who will go ahead and do that. You should know the nuances. How should you be able to portray that into the picture, right, from the perspective? It is not mandatory for you to learn everything, but you need to be clear, where do you stand, what do you do, right? So you need to know the basics of cloud ops, data ops primarily, right, which is part of data engineering, and MERN, basically, which is one of the most structured ways of doing things these days, right? To create an application. Once the application is created, you post it up to a cloud, right? Then the ML ops kicks into picture, DevOps kicks into picture to operationalize the solution and scale it across. That is how a data solution or a service is developed in most of the fields. Also applies to engineering as well, by and large, in the data-driven digital transformation. Yeah. So the motto here is, the general managers do not want you to develop the entire thing. They do not want an entire solution. It's the pie that you need to take and deliver. That's important. Let's take a simple problem, right? Let's say we have one of the rooms in IIT Madras, in one of the buildings, right? And we have an HVAC system, right? AC, basically, right? We have normally common AC or maybe internal window ACs, right? Or a split AC, right? You have the data loggers, right? Once you have the data loggers, right, the data logger gives you log data. That's where the first stage kicks in, right? We use MATLAB or Python, right, to understand the signal. Once you understand the signal, you pre-process the data, right? Understand the anomalies from the data. How do you process? There are some logs that will be not required. We need to sit down with the data logging team, right? Once the data is pre-processed and cleaned, and we are satisfied to differentiate between a good data and bad data, first, then we try to find the anomalies. And through finding anomalies, we go into the stage number 3, which is feature extraction. We extract the features, and you can see here, right? It's a very, very simple way of doing things, right? You can make it as complicated as possible. That's okay, right? But then you do a labeling and you test. I've just used a simple support vector machine, which predicts a normal air versus odor. Finally, you develop an app for your college, right? Management, saying that this is an energy monitoring system and monitoring AI system. It predicts the quality of the air in your room if there is an odor, right? And there is a failure probability of 87%. Click on this button, send, and it goes to the electrical supervisor to check on it. You can actually go ahead and automate this system, right, from the perspective, and make it all along. The reason that I shared this application to you is that most of the times I get a question that where would we find the data? It's not about the data. It's your approach towards dealing with things. And I'm sure a lot of you might have tried this, right? If you want to get it, right, you need to start experimenting. You need to get data out. There are multiple ways. I just showed it with an AC. You can do an entire ecosystem of your hostel, of your college, right, of your room, and so on and so forth, right? Anybody can do it, right? A simple example of how applied machine learning can transform into an application, as an example, right? Now, this can be from your room and going all the way to your car, right? From your perspective. Of course, there are complications which come into the picture, right? How do you develop the system? There are various systems of various places, but this is one of the most simplistic examples, right? From signal processing that you have definitely learned in physics to coming back to a machine learning support vector classification model, a simple classification model, by learning the code. So what is the path to industry 5.0? What do you need to do? So as I said, STEM, right? Science, technology, engineering, mathematics. One of them, you start learning with projects. That's a stage 1. You have to start from your foundations, even from the first semester, if I may say, right? You learn about IoTs and sensors, mechanicals, mechatronics, MATLAB, Python, at least the basics, right? Python is comparatively easier. Even MATLAB, a lot of people have access to MATLAB. It is not mandatory for you to be an engineer to only learn MATLAB. You can also download and do it. All students can do it, right? Launch your projects on LinkedIn, participate in hackathons, right? There will be more hackathons which will be conducted across, right, from the perspective. Even from Course5 will be doing a lot of things in this area, right? From the perspective, we have an entire scale of work, right? Focus on data engineering and analytics. Do not focus on 1% of the problem, which is dealing with probably computer vision or something like that. Your foundations of analytics has to be very, very clear. That is something that you should do from first semester to fourth semester. Then you should definitely try to get internship, depending upon your college's viewpoint, right? You during internship try to learn how consulting happens, which means even if you've created a solution or a mathematical model or a foundational model, right? Even the order problem, right? There will be no app which will be developed, right? That is what you learn. How do you convey that information to a manager, right? Or to a stakeholder who has no idea about machine learning, or even for an example, even about the scientific part of the game. He's getting smell or odor in his office. You have to explain this is how it works. You need to know the nuances of consulting delivery, of course, working in office, the new way of development, working with your team members. So problem solving and communication is something that you definitely need to learn in internship. You have to have your foundations being very, very clear prior to that. Then when you join a job or definitely get a job, you need to continuously learn. Invest time on yourself, right? That's very, very important. This is my personal purview that you need to invest a lot of time in yourself, skilling, unskilling and relearning. That's the only way that you would grow in your perspectives, right? It does not mean that post BSc you have to do MSc, and then you have to do PhD. No, it doesn't mean that. You have to continuously keep on learning, right? When I joined the manufacturing industry, I mean, when I started with my first project, if I remember, right, in Detroit, um, it was only the quality performance and the robots. Today we are talking about continuous mobility, right? We are talking about connected mobility. We are talking about data systems. We are talking about smart factories. We are now talking about metaverse and Web 3.0 to be utilized in omniverse. There is a path which continuously gets into picture. Do not be in the field of FOMO, right? You will not be missed out. You have to continuously keep on learning. Starting a job is your just first step in your career. From the perspective, this entails you to get into the entire foundational stone, right? From the perspective, and it's very, very rudimentary that you continuously keep on learning. When you get onto a job, you would not be able to find a right amount of time because everybody is busy, right? Everybody might have multiple projects, programs, and so on and so forth. You need to cultivate the culture in yourself in trying to interact and learn continuously. It doesn't matter whether you have to be brilliant in programming, right? There are multiple arenas, from data engineering to data analytics to consulting. All the areas are open for you. But there is a subtle step in data science that you need to take to be ready and accustomed into this perspective. You need to be a good analytics professional, to a problem solver, to a brilliant communicator. That's important, which takes time, of course, right, from the perspective. But you have a lot of information in your hand because there is a lot of guidance, mentorship, and there is a lot of work which is already happening. Right? From finance, the other part of the world is now engineering, right? So there will be a lot of guidance which you will get already. Before even concluding this part, I would say there are multiple areas through which you would be able to find your development scenarios, right? Mobility research and development, CAD, CAM, artificial intelligence and IoT, the one that I discussed, right, from the perspective. Customer experiences, right, zones to be created. These are the major areas of the work that you would get to be focused on. This is the future, and this is the path to your industry 5.0. I would rest it upon here. Thank you, and happy learning to everybody. I'm open to answering questions.
Thank you so much. I think it will really help us out to get into this industry and get ready with whatever is required. If anyone has any questions, sir, if anyone would like to get in touch with you.
Absolutely. So one is you can definitely get in touch with me on my LinkedIn ID, right? Chiranjiv Roy, PhD. That is what you would find me, right? It's with Aishwarya and the entire team as well.
Okay.
That is one. And with Course 5, we are already starting with Industry 4.0, right, as a practice. So there will be a lot of opportunities. But again, as I said, start from day one itself, right, from the perspective, right? That's very, very important. you can also get into the hardcore world of engineering. And a lot of people have actually come from there, right? From the perspective, it is still not dominated only by the people who only come from the engineering world, right? From the perspective, right? So, and that is why consulting comes into picture, right? So, analytics consulting is more an art rather than a science. That's important. Yeah. Would happy to answer any questions if anybody has any questions on YouTube or maybe LinkedIn.
Yeah. So someone has asked a question: how Web 3.0 and Industry 4.0 are going to contribute to manufacturing terms?
A very good point of view. Though it is still developing, the Web 3.0 primarily focuses on individual security, right? Security of dealing with information, right? We have already cut down the cookies, right? So you might have seen allowance of cookies, non-allowance of cookies, and so on and so forth. At a larger scale, Web 3.0 will primarily deal with this, right? Industry 4.0 has a lot of data sharing which is involved. Please do understand that if you have to get information, for example, you are driving a car on the road, right? It's a classic mobility example. You're driving a car on the road and you're ordering through a secured in your vehicle, right? In your car, you have an app, right? You want to order McDonald burger, right? Which is coming, let's say, after 2 kilometers or 3 kilometers. You want to pre-order, right? You click on a button and you pre-order. That has to go through the protocols of 3.0. When you go through the protocols of 3.0, your information would not be leaked to any other third-party provider. It will be a very secured information between you and the nearest store. And that's the kind of intelligence that would primarily drive. There are multiple use cases that will be coming into picture with 3.0 itself, right, from the perspective. But it will primarily be about the security. For example, one of the other things is about a designer, right? A new prototype that's created. That design needs to be shared with through a third-party mechanism. Though there are very secure channels and protocols, sometimes you need to share information through email itself, not even designs, to your vendor, right? From the perspective, right? So let's say you're making car, you need to source a tire. Just a simple example. But you send an email. You have to give the specifications, right? Those specifications will be very controlled from Web 3.0 protocols. Right? That those are the primary impacts of Industry 4.0 at this point to 3.0, Web 3.0.
There's another question. At the current stage, which programming language is most manufacturing?
I could hear you brief, Bhairavi, but what I could understand is what are the programming languages which are essential to get into the field?
Yeah. They asked which programming language has most scope in manufacturing.
Traditionally, manufacturing had always been a lot dominated primarily research and development. Please do understand there are different departments in manufacturing, right? R&D holds the maximum space. Then you have customer experience, you have after sales, you have sales, marketing, right? Procurement, finance, and so on and so forth. So when we develop digital and data-driven applications, R&D majorly uses MATLAB, right? From the perspective, not difficult to learn. A lot of engineering people already have been doing it, right? From the perspective. With that, Python being the new major generalized language, I think is picking up very, very well, right? That's being perspective. But again, as I said, don't be dependent on technology, right? From the perspective. But your fundamentals has to be clear with data structures and logic, right? Understand that part, right? That is something which you have to go from the ground up.
Okay. So how is cybersecurity effective in AI controlled devices?
A very large subject to be talked about today, but as I said, giving one of the examples, sharing of information, right, across inside the organization, as well as you can control a lot of information inside the organization, because you already have a lot of protocols, right? From the perspective, it is very sensitive. You cannot, if an organization develops something, right, that prototype before it comes to the market, it's a secured IP, right? The design should not go out, and so on and so forth, right? Privacy protection, and so on and so forth. Cyber security has a lot of problems. Not even just as like fintech, you have anti-money laundering and transaction monitoring developments that you do in your finance. Those problems are also applicable here, basically, right? For example, in the use case that I just told you, right? You ordered for a McDonald's burger, right? With a transaction, right? From the perspective, you paid it through, let's say, Paytm. The Paytm, so your money from the car, the signal has to be good. It has to go through Paytm, and through the Paytm channel needs to reach to the Paytm, to the McDonald's owner, right? From the perspective, and they need to get a transformation, a confirmation as well, right? So if one of the parties fail in between, you're gone, and somebody leaks that information, your credentials for Paytm will be out. That is where cybersecurity primarily comes into picture. A lot of them primarily are related to shared mobility area and connected mobility area, basically, where you have multi parties, right, who are dealing with a share of information, right, from the perspective. So you have the original manufacturer, then you have the equipment manufacturers, right, from the perspective. Even people who make screws, bolts, and everything, right, every spare part, right, which is there, and then the entire service industry, right? You take an app and you take a bike on rent, right? Today you just scan your system and take the bike on rent. Your credentials will be leaked out in the market, right, from the perspective. So cyber security holds a lot of grounds, and multiple use cases will come from the perspective.
So someone asks, is there any prerequisite for MATLAB course, and how to start projects in it?
Generally, no prerequisites. Basically, as I said, right, everything is about logic. That's a programming language. It's a very visual programming language. People have been using it for a long time, right? From the perspective, it is not complicated as C++, right? From the perspective, so it's not about the BSc or MSc computer science people can only do it. Everybody can do it, right? Yes, it's just that. I mean, I came from the stats world. I took about 2 months to learn MATLAB. A person coming from a computer science background might take 2 weeks. That's okay. That's fine. Ultimately, you have to learn it, right? From the perspective, you have to be language agnostic. That's important, right? The logic remains the same.
Someone asks, what is the person who's asking works as an outgoing quality control? So what is the scope of customer perception and level of quality in the competitive world?
I'm not able to hear you much, Bhairavi. Would you be able to repeat the question once again, please?
Yeah, sure. The person who's asking this works in outgoing quality control. What is the scope of customer perception and level of quality in the competitive world to play around?
Thank you for the question itself. Quality and production have been the forefront of manufacturing in every field, any industry you take, from automotive to energy to oil and gas, everybody, right? The products that are coming, right, for example, the spare parts and the products that you're delivering to somebody, both has a lot of quality and warranty value. For example, right, in automotive, right, you take the spare parts and fit into an assembly line, right? You make a car, right? Some of the spare parts you make yourself, right, and some of them you get it from outside. multiple of them, right? It can be airbag to your tires, right? One of the biggest examples, right? A tire. You need to inspect all of them. There has to be 100% standard quality which need to be maintained, and artificial intelligence has already done a huge amount of work in quality and warranty manufacturing, right? From the perspective, what is incoming and as well as what is going out of the production line. So both need to be very much done. According to Kanban and Six Sigma and the policies that we have already applied, the biggest revolution which has come in Industry 4.0 is utilizing machine vision, computer vision, and sensor based methodologies to inspection of every product 100%, right? We still be increasing, right? From a perspective, you can find defects at a lot level. Definitely we maintain a 99% plus of quality, right? But that 1% gap is also filled by the artificial intelligence, right, or data science, right, from the perspective. So there is a huge amount of work in the perception area.
Okay, sir. So am I audible now?
Yes, you are. Thank you.
Yeah.
This is good.
So, okay, sir. So someone asks, what is the disadvantage of digital marketing?
What is the disadvantage of digital marketing? I would not say a disadvantage, but primarily the fundamentals of marketing is to convert and get customers, right? Consumers, right? To buy you something, to sell you something, and so on and so forth, right? It does not take care of a lot of times, since a lot of artificial intelligence has entered into this field, right? From the perspective, which have been trying to take out a lot of biasness, right? Ethically, right? Should somebody be releasing my data? So you captured my data, right? For example, and you took my phone number and so on and so forth, or my IP address to give it to 10 more people. That is beyond ethics, right? You should not never do it, right? From the perspective. So I think that all would be all controlled. But digital marketing, again, it's been very, very huge and wide, right? That's why once you type something into Google, you will find it on your Facebook, right? So even if you're trying to find a pencil, so you will have all the ads of pencils, right, in the world, but you never wanted that, right? So I think there are a lot of control and personalizations which will come into picture. A lot of ethics is getting discussed today, but these are some of the disadvantages. But primarily marketing is important. You get to get things in cheap, you get in variety, and that's where the advantages are. But I would say limitations of digital marketing is primarily to keep converting, right, from the perspective. That's the DNA of marketing itself.
So someone asks, what are the basic things to start a business related to data, and start a business with minimum resources is the highlight here.
Depends upon the business that you are getting in. So in digital manufacturing, if you want to start, because primarily it's from a manufacturing background, right? From the perspective, what is the product that you are developing, or you are just reselling, right? From the perspective, you want to become a distributor, dealer, and so on and so forth, and you can utilize data science, right? From the perspective, right? How much products? So if you are, let's say, a dealer, right, of some spare parts, for example, right? You would be very interested to know what would be your demand and growth in the next 2 months, 3 months, right? From which geography, which place, who is your major retailer, right? As a distributor, as a retailer, I'm talking about the services side, right? From a retailer's perspective, you would be very interested to know what is selling more, which type of customers take. It's primarily a B2B market, primarily in manufacturing. Now there is a B2B2C, right? From the perspective. So, for example, food and beverage company which makes let's say aerated drinks, soft drinks, beverages, right? You are a supplier or a producer of the metal sheet which actually makes your cans, your aluminum cans or tin cans that you make, right? They would like to know, as in if you are a producer of that, you would like to know who wants to consume more, right? From the perspective as a manufacturer. So manufacturing to services, including distributor to retail ship, everybody can utilize and get along with that. Data, digital and data sciences, right, and AI will help you accelerate that 10 times on the perspective. How would you start it? The amount of resources, other than uh, the hardware part of the game, right, where you would have to procure, you have to sell something and so on and so forth. For data science, you require a person, at least one or two people, and you can take help from multiple analytics companies like us and so on and so forth, and multiple places, right, to invest into creating science from the day one itself, right, from the perspective. All of us can contribute from the perspective, right, and everybody can chime in to solving a problem, right. That's important. Right? It doesn't require external effort other than your buying and selling perspective. But what is more important is you need to give time to learn, right? Even if you are starting the business, you cannot be dependent upon a data scientist to make you a rocket. That's not his or her job.
So someone asks, how important is it to leverage digital manufacturing as an indigenous hub for our country in the evolving IoT and AI global value chain?
Fantastic question. In Indian subcontinent, primarily, we always have been into major part of the services part, right? From the perspective, right? The automotive picked up a lot, right? But from the other perspectives, right? It's been services which has been always been dominating, right? Now, research and development is stepping in, right? I mean, NASCOM to multiple bodies are trying to promote. Even Analytics India magazine and multiple organizations have been able to try and promote. There are analytics organizations, right, who are trying to get into the ecosystem. So the ecosystem in manufacturing, digital manufacturing, is picking up a lot. The major part of the people who are producers, right? Let's say manufacturers, engineers, engineering organizations, right? Now understanding the major value because they have taken either understood that their counterparts in Europe, America, Japan, and so on and so forth have been leveraging, right? And being a self-starter, they have dominated or found a lot of value. The challenge here is the talent part of the game, right? Where R&D, analytics, and AI have not been able to mix too much of together because of multiple reasons, right? From the perspective, right? Data not being open, data not being clear, right? As a data scientist, everybody needs data, right? And most of the 98% of the time, there is no data. So to start from scratch, you need to understand the domain. So R&D has got a lot of future in this value chain, right? From the perspective, India to be in the forefront, to be perspective, is that with the enthusiasm that we have, and we are in the mass production scale. So please do understand, in the digital manufacturing in the last 2 years, the demand for digitalization and acceleration has crossed at least 2 times of its requirement. Of course, pandemic is one of the reasons. Currently, there is a bit of recession, which is also on the loom, war, and so on and so forth. So everything comes in that, right, from the perspective. So in the next 20 years, it will be a lot of work which will be coming into this, right? So the scope of not just R&D, not limited to R&D, but to the entire ecosystem is a lot large.
So I think you answered this question, but someone just corrected me. I think I read it wrong. The question was, what is the disadvantage of digital manufacturing? So would you like to add upon it?
I don't think there is any disadvantage of digital manufacturing. So the only thing difference between industry 4.0 and 5.0 is that 4.0 primarily only focuses on digitalization and automation, right? The human aspect is getting missed, right? Which is the actual reason where Andrew Ng to everybody is talking about, and that will come into work in industry 5.0. It's all about the human and the machine knowledge, right? So the human and the robot has to parallelly work together, right? So just an example, if you create an app for your bicycle serviceman on the road, or maybe a bike service engineer, right, in a service station, he would expect you to give him or her a system through which he can train the model in his way, rather than you developing a model, right, which you would have learned in your own way, right, from the perspective. He or she, right, the end consumer should be able to contribute. And that's the experience of machine learning that we are talking about. I think that is where it is. Disadvantage, none. Enhancement, yes. You need to get the human in the loop, because you cannot replace human being, especially in engineering. It is not possible, right, from the perspective.
So I think you've all answered all the questions here. Sir, thank you so much for sharing with us your very precious time and answering all our questions so patiently. This was really a very insightful session and will definitely help us all to walk our paths into this industry. I'd really like to thank you. Sir, any words of wisdom you would like to share before we conclude the session?
No, thank you again, IIT Madras, and all of you being patient to listening to me, and some of you will hear the recording as well. Manufacturing is a journey. You need to take steps one by one. If somebody tells you that only an engineer can get into the field of manufacturing, no, it doesn't. It is not the norm, right? Otherwise, Elon Musk would have not been the CEO of Tesla, right? From the perspective, if he can do that, all of you can do it. Thank you so much, and have a great learning journey. Just keep on learning. Thank you.
Thank you so much, sir. Balaji, sir, we can stop the recording now. Sir, you can leave according to your convenience. It was so good to have you here. Thank you so much.
Thank you, Bhairavi. Thank you, everybody, the entire management. Good day.